Hi everyone. So how was the quiz? Okay, I'm audible, right? Hello. So how was the quiz? Anyone who has attempted? Okay, doubt solver is one user. So what is your name, doubt solver? Okay. So quiz is actually not tough, to be honest. I mean, it is not easy, definitely. For sure, it is not easy. But it's okay. I mean, it's not very, very tough also, right? So yeah, we will not discuss quiz now. Okay, we will discuss some gate PYQs. Quiz will be open for one more day, so don't worry about it. Okay. Will solving PYQs help in the quiz? No, nothing can help in the quiz actually. So quiz is very much different from PYQs. So you solve all the PYQs, it won't be any use in the quiz. Okay, so you can solve obviously, but it won't be much useful for the quiz. Quiz questions are completely different. Okay, so let's just start. Okay, Twinkle is saying nothing can help is the best motivation ever. Okay, so let's just start. Let's start with a very good question, which I wanted to solve. This question has been asked in GATE 2017, and it's really a very nice question. Has anyone solved this question? Okay, okay. So let's see this question. What they're saying, my voice is not there. Okay, it's proper or like voice is less. It's breaking. Okay, okay. So ठीक है, it's audible, right? No, I think it's proper. Okay. So let's just start with this question. What they're saying, let A be n cross n real valued symmetric matrix. Hello? I think there is some problem with the voice. ठीक है, अभी सही है ना? Okay. So A is n cross n real valued symmetric matrix. Okay. So they have given that it is a symmetric matrix of rank 2. And then they have given something which is basically all the elements of A getting squared, and then you need to sum all the elements, and then they're saying the squared sum of all the elements is 50, right? So this is, see, if you just read this, what they have given is squared sum of all the elements. This is what they have given, right? Can you understand this? This is double summation. So it means that for every I and j, like it's just like a two-fold loop. For every I and j, you have to unroll it, and then you have to write it in such a way that a11 square plus a12 square plus a13 square plus a1n square plus, right, plus a21 square plus a22 square plus a23 square plus dot 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 a2n square, and then ultimately it will be till a n square, right? A n square. So it's a square matrix a n square, and that all the summation, all the element summation, squared summation is given to be 50. Cool. Then they have said something about the eigenvalues of A. Now they're asking something about the eigenvalues of A. That's really a bit unconventional question, and I have observed that on the gate flow also, like there is no satisfactory explanation. Yeah, like I did one of the comment, but before that I think there was no very good explanation. So let's just try understanding this question. Suppose you write A, okay, uh, a transpose A, let's suppose you write, which means let's suppose A is something like this. Let me say A is something like this, which means this is first column of A, which is, let's suppose, small a1. This is the second column of A, which is, let's suppose, small a2. Similarly, this will be small a3 and so on, right? And then ultimately you have a small an. What are these small a's? Can anyone tell me? These are the columns of A. Okay. So these are the columns of A. Now, yeah, columns of A, you can call it more precisely. Now, if you talk about A transpose, then A transpose will look like something like this, which is basically like you can say this is A1 transpose. I mean, this A1 will look something like this, right? After the transpose, A2 will look something like this, and similarly, AN will look something like this after the transpose. So this is how A looks like. This is how A transpose looks like. To be honest, I need to like technically I need to write the transpose because this is not the A1 vector. A1 vector is the column vector. You take a transpose of this, then it becomes a row vector. Okay. So I mean, this is just one notation that we can do. Like it is up to us how we are doing it. So it is just one notation that we are doing. Generally, people do not even write like this. Generally, people write like this. Okay. Generally, like this is A, like that. And if they have to write A transpose, then they will be writing something like this. I mean, what is the difference between these two notation? There is no as such difference. It's just that I'm not putting the arrows. I'm not putting just the arrows. I'm just writing those numbers. Do you remember there was one gate PYQ? Like there they have given that okay, summation of AI is equal to B is equal to summation of AIs, and then they've asked about unique solution and all, right? I don't remember the exact year, but yeah, there was one gate PYQ, right? We have solved, yeah, gate 2017, yes. So in that gate PYQ, I think I'm again not 100% sure, but I think they have represented A something like this, A1, A2, A3, like this, right? In that particular gate PYQ, they have represented like this. So anyway, like this is just a common notation that people follow. Okay. Now, let's just see that what will be A transpose. So this is A. This is how A looks like. This is how A transpose looks like. Now I will tell you that why I'm calculating A transpose. See, the question is saying that you have given a squared summation of all the numbers. Okay. Now I will tell you that why we are calculating A transpose, but or maybe A transpose A, just for the visual purpose, it will be easier to visualize. So A transpose A will be, can anyone tell me? So it will be, it's very interesting term. So let me just tell you, this is A transpose, right? And this is A. This is A. So A transpose A will look very nicely. And ultimately, like if you multiply this A transpose and A, then this vector is getting multiplied by this vector, isn't it? So these two vectors are getting multiplied. Now here, let me just write it A1 square. Okay, A1 square. So A1 square is just the length of this vector. Length of this vector means this vector is getting multiplied by this the own vector. So basically, ultimately, it will be length of the vector. Now, if I ask you that what is this in terms of this capital Age, in terms of capital Age, which means in terms of this is, see, this A1 is the first column, right? A1 is the first column. Okay, what I have written, this double, this is actually okay, this is called norm. Okay, this is called norm, but anyway, the notation is not very important. But let me just tell you that what do I mean by that? Suppose you have a vector V that is basically 1 2 3. Okay, and then you have V transpose that is 1 2 3, right? Now, if I ask you, can you just multiply V and V transpose? Maybe V transpose V. If you just do it, then this will be what? This will be 1 square plus 2 square plus 3 square. Actually, this is called length of this vector. Okay, dot product or length of this vector is also called, like if you are multiplying the same vector, right? So this is also the length of the vector V. I mean, I think the length is for the length we need to take the square root also. I think that. So this is basically called norm 2. Okay. Anyway, the perfect term is not very much important, but I think this is called norm 2. So anyway, like this is just a dot product between these two, and finally you get the scalar. But ultimately you get the squared summation of all the numbers, right? So if you have A here, or any vector here, you have any other vector here, so you will be getting the square of that particular vector, like length square. Okay, so you will be getting length square, or maybe I can say A transpose A1 transpose A1. Okay, ultimately this is an scalar. Okay, this will be a scalar number. Is this okay to everyone? And then you will be having here A1 transpose A2, and then A1 transpose A3, and so on, right? So if you multiply these two matrices, then you will be getting something very nice. Okay, let me tell you what you will be getting. If you multiply these two, then you will be getting something like this, where A1 transpose A1, A1 transpose A2, A1 transpose A3, something like this, right? And then A2 transpose A1, A2 transpose A2, A2 transpose A3, then A3 transpose A1, A3 transpose A2, A3 transpose A3, right? Suppose that A1, A2, A3 are there. Let me know if that is clear. If you are multiplying A and A transpose or A transpose and A, you will be getting something like this. Okay. Now, all of these are scalars only. All of these are scalars, right? But this is basically the squared summation of the first column. If you look at this A, then this is A1, right? Do you remember the A1? Now, if you are doing A1 transpose A1, then it will be the squared summation of all of these numbers. Okay, Shubhadeep is asking that I enrolled yesterday. How should I start? Like, I'm very behind. Course is progressing. I am trying to catch up. So Shubhadeep, don't worry. Like, you will be able to pace up, I think, in just 10 or 15 days, because we might not be able to provide the lectures at which you can definitely watch, right? So let's suppose we are providing the lecture for 3 hours per day, then like you can definitely extend your number of hours to be 4 or 5 hours per day for the initial few days, and then definitely you will be able to catch up. Okay, so here this scalar number, which is A1 transpose A1, isn't it the squared summation of all of these? This is just a vector, right? So here ultimately that A must be something like this. A must be 1, 2, 3. So this is isn't it 1 square plus 2 square plus 3 square, right? And then similarly, if I ask you this particular number, I'm just asking you diagonal numbers. Okay, so the diagonal number will be again the square summation of these this particular vector, then a square summation of this particular vector, like this, right? So these diagonals are basically these diagonals, this one, this is covering all of this, what is written here, all of this, what is written in this slide, all the numbers, right? Because just see here, this is the summation of all the like squared summation of all the numbers of in A, right? This is the squared summation of all the numbers in A. Now, isn't it the same thing? This is a squared summation of all the numbers in this column. This is a squared summation of all the numbers in this column, like that. So here the diagonal numbers are squared summation of all the numbers in A, isn't it? Yeah, thank you, Shivadeep. So what you can say about this A transpose A? What you can say about this A transpose A? The trace of A transpose A, trace of A transpose A is given to us, which is 50. It is given to us. Okay. Indirectly, they gave you something else, but finally it is something else. I mean, instead of directly telling you that it is a trace of A transpose A, they have told you that it is actually the squared summation of all the numbers, right? It is actually A11 square plus A12 square plus A13 square, like that. And ultimately, it is just a trace of A transpose A. Once you understand this, then you will be able to understand the complete question. Okay, so how it is trace? See, let me just okay, I will give you the concrete example, but before the example, tell me, is this okay to you, that how we are multiplying A and A transpose A, this matrix, how we are getting this matrix? Is this okay? Okay. Now this first number is a scalar itself, which means this first number itself is basically this vector square, which means this column is called all the elements in this column is summation of all the square like square summation of all the numbers in this column, this first number itself. And let's not worry about these numbers, whatever these numbers, I'm actually not worrying about these numbers. Okay, so let's not worry about any other number, let's just focus on the diagonal numbers. So the second diagonal will be the square summation of this second vector, third diagonal will be the like third number will be the square summation of this. So basically if you sum all of this, then you are getting a square summation of all the numbers here, which means trace of A transpose A is actually given to us, which is 50. Should I explain to you using the example? So see, this is A. Let's suppose it is 1, 2, 3, 4, 5. Okay. Let me just take 1, 2, 4, 5. Okay. Let's just take a small matrix and let's just take A transpose. It will be it 1, 2, 4, 5, right? Okay. So now let's just do A transpose A. Tell me the first number that you are getting. The first number will be, it should be basically 1 square plus 4 square. Let's just see. It should be basically this 1 square plus 2 square. So just see the first number. The first number will be 1, 2 multiplied by 1, 2. Isn't it? So it will be 1 square. I mean 1 into 1, 1 square, and 2 into 2, 2 square. 1 square plus 2 square. Right? The second number will be something, but let's not worry about it. I mean, it is 1 into 2, 1 2 multiplied by 4 5. So 1 into 2 plus 1 into 4 plus 2 into 5, right? But let's not worry about it. Now what is this number? This is 4 5 into 1 2, 4 into 1 plus 5 into 2. But again, let's not worry about it. Let's just focus on these diagonal numbers. This is 4 5 multiplied by this row multiplied by 4 5. This is again 4 square plus 5 square, right? So basically all of these numbers, if you sum all of these numbers, then this is 1 square plus 2 square plus 4 square plus 5 square, which is actually the summation of square summation of all the numbers in A. Yes. So actually what is happening here? Here you have A1 transpose A1, and then you have here A2 transpose A2, like that, because A1 transpose into A1, and this is A2 transpose into A2, something like that, right? Now, this is actually, this A1 transpose A1 is actually the first column square, right? I mean, this is basically square of all the elements here. Square of all the elements here is here. Square of all the summation of square all the elements is here. So if you sum all of this, then it is actually summation of all squared summation of all the elements in A, right? So basically, it is given to us that trace of A transpose A is 50. I mean, they gave you something else, but ultimately we deduce that a trace of A transpose A is 50. See here, see, they have given this information, but from here now, okay, if you are asking me that how to approach it, let me be very honest with you, you cannot. Okay, so like, sorry for again that kind of motivation, but you cannot, like, it is I was able to think it because I know, or like, I have been into this world, like I have actually like I can say I have lived that world. Okay, so I have been into this machine learning for 3-4 years. Now I know all of this, like I can actually see the question, I can understand that, okay, where it is linking. And that is the reason that till this point there is no gate or flow answer which is linking this particular concept and then what I just told you, right? So नहीं बुक की बात नहीं है, these are the actually common things in machine learning. मशीन लर्निंग में ये सिमेट्रिक मैट्रिक्स जो है ना, ए ट्रांसपोज ए, ये इतनी ज्यादा कॉमन है, you will be used to of this. Then whenever you see anything related to A transpose A, then your mind will automatically get clicked that, okay, they are talking about something about A transpose A. Okay, so that is the reason that is why I was able to think it, to be honest. Okay, I don't know there is any other intuition that you can have. Okay, so basically they have given the trace of A transpose A is 50, right? I mean, you can do A transpose into A, and then finally you will be getting this particular number. Cool. So is this settled till this point? Can you deduce that this is a trace of A transpose A? Now let's just solve the question. Okay. Now we are yet to solve the question, obviously. Okay. So they have also given that A is symmetric matrix. They've also given that A is symmetric matrix, which means what? A transpose and A are equal, because this is what they have given. See here, squared symmetric matrix, right? Squared symmetric matrix they are saying. If it is squared symmetric matrix, then I think you can easily figure out that A transpose and A both are same, right? Which means they have actually given the trace of A square equal to 50. Trace of A square equal to 50, right? They have given like this. I mean, they gave you this, but ultimately they gave you trace of A square is 50. Now, let's just see if we can solve this particular question after this, right? Okay. So now from here, what we can say, see, they are asking what? They are asking about the eigenvalues of A, right? So like A is given something and the one eigenvalue must be. So they are asking about the eigenvalues of A. So let's just go to the next page. See, ultimately they have given the trace of A square to be 50. It means what? That do you remember that there were two magical properties? One of them is that trace of any matrix is summation of all the eigenvalues of this, right? Now tell me if A has eigenvalues, let's suppose, which is lambda 1, lambda 2, like that till lambda n. Okay. Then what are the eigenvalues of A square? Okay, if you have not watched that lecture, actually this is in the lecture 10. Okay, in the lecture 10 I have mentioned it. So the eigenvalues of A square is lambda 1 square, lambda 2 square till lambda n square. So whatever is the eigenvalue of A, you can just take the square and you will be getting eigenvalues of A square. Which means they have given this. It is same as saying that lambda 1 square plus lambda 2 square till lambda n square is actually 50. See, they gave you something and then finally we have to deduce something else, right? Okay. Right. This question is very, very tricky. Okay. So till this point, I hope it is okay. I will revise everything about this question. Don't worry. Let me just first finish this question. Abhi actually शुरू ही हुआ है. Now they have said that that rank is 2, right? Rank is 2. What does this mean? Let's suppose A is n by n, right? Let's suppose A is, just to give you the example, A is 10 by 10. Rank is given to us, which is 2. It means what? Nullity is what? 8. Nullity is 8. That's great. Do you remember that nullity and eigenvalues are related? See, it's not full rank. That is for sure, right? It is not full rank. Sure. If it is not full rank, then one of the eigenvalue must be 0, right? One of the eigenvalue must be 0. Swadeep, you can ask the out of order doubts after the class, which means like once I say that okay, the class is over, you can ask those doubts, right? Or maybe you can ask in the Telegram group also. Okay. So see, one of the eigenvalue must be 0. Is this okay to everyone? Like you must be having one of the eigenvalue 0. Okay. Rank is 2. It means what? It's not a full rank matrix. Because full rank must mean that rank must be 10. It means there must be eigenvalue 0. I mean, because determinant is 0 and then eigenvalue must be 0, right? That's the only reason that rank is less than 10. So one of the eigenvalue must be 0. Now, what I am trying to figure out is that what should be the power of this? See, matlab jo bhi characteristic polynomial you will be having, okay, whatever the characteristic polynomial you will be having, I'm just trying to figure out that what should be the power of this lambda power, lambda, right? So lambda minus 0 or maybe just lambda. What do you think? It is a symmetric matrix, right? Symmetric matrix means what? That AM and GM both are equal. Which means that nullity is given to us. Nullity is in terms of eigenvalues. Can anyone tell me? Nullity is number of linearly independent eigenvectors for lambda equal to 0. कॉम्प्लिकेट कर दिया क्या? एक मिनट रुको. Okay, Kshitij is saying ki yes, complicate. Complicate के लिए you are saying yes, or you are saying that nullity is number of linearly dependent eigenvectors. ठीक है. Okay. So okay, यहाँ तक is this okay to everyone? That rank is 2 and nullity is 8, right? Okay. Now let's just try figuring out that what should be the like we are for sure. See, from here, since it is not full rank, so we are sure that one of the eigenvalue is 0, right? Now what I'm trying to do is that I'm trying to figure out that what should be power of that 0. Okay, this is what I'm trying to figure out, and I will tell you why. Okay, let's just see that that what should be that power. Okay, see, this nullity is 8, and what does this nullity means in terms of eigenvalues? This is number of linearly independent eigenvectors for lambda equal to 0, right? Okay, Twinkle, is this okay to you? This nullity is number of actually this is what we have discussed in the live lecture and in the lecture number 10, I think, right? So number of linearly independent eigenvectors for lambda equal to 0. Basically, nullity means number of free variables, right? See, let me just tell you why that is the case. Nullity means number of free variables. So number of free variables are 8 in the solution of Ax equal to 0, right? So or maybe in just A. So in A, the number of free columns are 8, which means let's suppose these are the 8 free columns, and then you have 2 pivot columns, right? So let me write those 2 pivot columns first. So you have 2 pivot columns. Let's suppose this is the pivot column, this is the pivot column, and these are the free columns, right? Okay. Now, which matrix is this? Which matrix is this? This is A, right? I'm talking about nullity of A. So this is A. So this is a matrix which is A. Now the thing is that can you just think this A, I mean in terms of eigenvalues, which means see A has 8 free columns, and what does this mean is that if you talk about lambda equal to 0, then this is same as A minus lambda I, isn't it? This is also same as A minus lambda I if lambda is 0, obviously, right? For lambda equal to 0, this is not just A, this is A minus lambda I also. So solution of Ax equal to 0 will be having 8 linearly independent vectors, or maybe solution of A minus lambda I equal to 0 will be having 8 linearly independent eigenvectors, right? So basically here nullity is number of linearly independent eigenvectors for lambda equal to 0. If you want, you can remember this. I mean, nullity is basically in terms of eigenvectors, it is number of linearly independent eigenvectors for lambda equal to 0. Okay. So it means GM, right? GM is given to us, which is 8 for lambda equal to 0. Right? Now, what does this mean? Then AM could be 8, could be 9, or could be 10. At most, it could be 10 because like I'm taking this as 10, right? So AM could be 9, could be 8, or could be 10. But again, they have given that it's a symmetric matrix. That is why these two are not possibility, because AM and GM both are equal. Only possibility is this, right? Only possibility is this. So basically, you have finally came up with the idea that rank is 2. It means the characteristic polynomial will look something like this: lambda power 8 into lambda minus lambda 1, right? Maybe like, okay, rank is 2. Yeah, it is. Can it have 3? So this is 8. Can it have something like this? 3 eigenvalues? No, why it cannot have? So quiz discussion we can do after the 1st of April. So on the 2nd of April we can do, okay? Because 2 days we will be busy, so that is why on the 2nd of April we can do. But to be honest, for the quiz, I suggest everyone just participate on the gate overflow. See, if you are just a passive user, if you are just thinking that okay, you can just discuss in the exam or in the live class or like that, it is okay. But if you participate, then it will be automatically useful for you, right? Okay. So characteristic polynomial could be something like this, right? Cool. Now, or maybe like this also. Like, I'm not saying it cannot be like this. Maybe the eigenvalues are repeating, right? Maybe like this. So like this or like this does not matter to us. So ultimately, the eigenvalues from this characteristic polynomial. Can you tell me the eigenvalues of A? What are the eigenvalues of A? Let's just consider one of them. You can consider any one of them. Does not matter to me. Okay. But what are the eigenvalues of A? Yeah. So eigenvalues of A is basically 0, which is repeating 8 times, right? 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Full rank means the rank of a matrix is n. For the square matrix, generally we use full rank. So n into n, for the n into n kind of matrix, we use full rank. Full rank means it's having the rank n. Okay, and then lambda 1 and then lambda 2. Okay, so these are the eigenvalues of A. Now, what are the eigenvalues of A square? Just same as this, and lambda 1 square, lambda 2 square, right? Okay. So what is the summation of eigenvalues of A square? What is the summation of eigenvalues of A square? It will be lambda 1 square plus lambda 2 square. And it is given to us. See, ultimately, they have given the trace. Trace means summation of eigenvalues of A square, which is given to us lambda 1 square plus lambda 2 square equal to 50. And what are the lambda 1, lambda 2? Are the eigenvalues of capital A. Okay. So basically, this information was given to us, and this information, ultimately, we have to deduce that this information is lambda 1 square plus lambda 2 square equal to 50. And what are the lambda 1, lambda 2? Eigenvalues of capital A. I know most of you have already lost the track what I'm talking about. So let's just quickly finish this question and I will revise. Okay. So now this is lambda 1 square plus lambda 2 square equal to 50. Now using this particular equation, what can you say about the lambda 1 and lambda 2? That's what they're asking in this question. Okay. So if someone says that lambda 1 square plus lambda 2 square equal to 50, then what can you say about the lambda 1, lambda 2? Can both the lambda 1 and lambda 2 be greater than 5? If both the lambda 1 and lambda 2 are greater than 5, it will be greater than 25, it will be greater than 25. Then ultimately it cannot be 50, right? So both cannot be greater than 5, neither both can be less than minus 5, right? I mean, if this is minus 5, this is 5. Now both of the lambdas cannot be here, lambda 1, lambda 2. Similarly, both of the lambdas cannot be here, lambda 1, lambda 2, right? Now let's just see the options. Maybe both the lambdas could be 5. If one of them is 5, then okay, automatically the another one will be minus 5 or 5, something like that. So maybe like you need to balance it. Basically, both of the lambdas cannot be at the same time, cannot be here, neither they can be here. If one of the lambda is, let's suppose, 6, then you can find out the another lambda like that, right? So there are many possibilities, but yeah, so let's just see the options. One eigenvalue, they are saying one eigenvalue must be within minus 5 and 5. Yes, right? Because both the eigenvalue cannot be here or here. One of the eigenvalue must be within minus 5 and 5. From where did you get n equal to 10? No, I have not got n from anywhere. Like I just assumed just for the sake of explanation. Okay. I mean, n could be, you can take n, like just, I will come back to this. You can take n, anything. It like just for the sake of explanation, I assumed it. Okay. So both of the lambdas cannot be either here or here. So one of the eigenvalue must be in between. So yeah, that is why this is true. The eigenvalue with the largest magnitude must be strictly greater than 7, strictly greater than 5. So is it always the case that it should be strictly greater than 5? Both can be 5 also, right? Both can be 5 also. Both can be minus 5 also. Both can be 5, both can be minus 5. Still you can satisfy this equation. So that's why this is false, right? So that's why only one is true. So B is the correct answer. Should we do it again? Let me just try doing it. Okay. So what they have said is this. Okay. See, now again, I'm just telling you that if you do not understand this question, that's perfectly fine. If you skip this question, that's also perfectly fine. This is like rare questions that they may ask. And honestly, these kind of questions will not also improve your any skill, because whatever we are using in this particular question may be just limited to this question. Because see, this like from here to here, I don't think that they will ask it again. Okay, so there will be a questions where like if you are learning something, those learnings will be helpful in other questions, but this is a kind of question where you are learning something maybe just limited to this question. So that's why itna is question ko don't give a much footage. Okay, cool. Now what they're saying is that this is, yes, I will do it. You can just tag me on the gate or flow if the question 26 is having some problem. I will just check it. Okay, so let's just see this. If this is having this is 50, which means the trace is 50. Okay, so I'm not going to repeat at least this part. The trace is 50. Now since matrix is symmetric, that's why trace of a square is also 50, because the matrix is symmetric. Now given that A is having rank of A is 2, it means nullity is 8. Or in other words, that lambda, nullity means GM of lambda equal to 0. GM of lambda equal to 0, right? I mean, basically, I'm taking n equal to 10, A is 10 by 10, A is 10 by 10. So in that case, nullity will be 8. And nullity 8 means GM of lambda equal to 0. Since AM and GM both are same in this case, so AM is also, AM of lambda equal to 0 is also 8. Which means you have lambda power 8 here in the characteristic equation, right? And then which means lambda equal to 0 must be repeating 8 times. if it is not symmetric, then it may repeat multiple times also, more than 8, but never less than 8, because nullity is 8. It has to at least give me 8 linearly independent eigenvectors. So that's why it has to at least repeat 8 times. Just for one linearly independent, it has to repeat 1 time. For 8 linearly independent, it has to repeat 8 times, and it may repeat 10 times also. Okay, like if it is not symmetric. But yeah, in case of symmetric, it exactly has to repeat 8 times. Now what about the other eigenvalues? Could be like this, right? Could be like this. Maybe some eigenvalue is repeating, or maybe you have two eigenvalues, right? Lambda minus lambda 2. Okay. Is this okay to everyone? Now see, you have to get this characteristic equation right. Once you get it, then you can solve this question. Now it means you know the eigenvalues of A, which are 0, 8 times 0, and lambda 1, lambda 2. Now can you get the eigenvalues of A square? Yes, 8 times 0, and lambda 1 square and lambda 2 square. And then they have given trace means lambda 1 square plus lambda 2 square equal to 50. And then they're asking something about lambda 1 and lambda 2. What should be their range? Okay. Just give me a second. Let me just plug in the charger. Okay. Nishant is saying we cannot directly say, since rank is 2, we have lambda 1 and lambda 2. Rank is 2, then lambda 1 and lambda 2. No, it could be just lambda 1, right? Lambda 1 could be just there. I mean, I have not got you. Okay. Sai, can you tag me in that question? Okay, please tag me in that gate overflow question. So anyway, coming here, that lambda 1 square plus lambda 2 square, finally they have give you 50. So this equation finally should mean to you lambda 1 square plus lambda 2 square is 50. And then they're asking something about the lambda 1 and lambda 2. Okay. So that is all. Cool. Now let's just go to the next question. Actually, this question is, to be honest, quite tough. Yeah. So one is correct and second is not correct. That's why B is the correct answer. Let's just solve this question. This is also again very interesting and nice question, but fortunately it is solvable. Sai, I'm telling you last time, please do not disturb the class. If you have any doubt on the quiz question, then you can just tag me there. Okay. So now let's just solve this GATE 2007 question. So what they are saying is that given a matrix A, what is the maximum value of X transpose AX? Right? They have asked this, that what is the maximum value of X transpose AX, where maximum is taken over all the X that are unit eigenvectors of A. See, do you remember, if X is eigenvector, then Kx is also eigenvector? Do you remember this thing? So if X is eigenvector, then the unit version of this, okay, whatever is the unit version, which will be actually, you need to divide by the length of this X. This will be the unit version of this. This is also eigenvector, right? I mean, you can actually make that length 1. So what do I mean by that? I mean, let's suppose you have vector 1, 2, 3, and then if you want, you can just divide by 9 plus 4 plus 1, square root of 13, and then finally it will be unit vector, right? Anyway, like that's not important, but yeah. So basically, you can divide by the length of the vector, and then it will be unit vector, and then that is also eigenvector. So what they're saying is that they want to find out x transpose ax, value of x transpose ax, maximum value of x transpose ax. Okay, they want to find out the maximum value of a transpose ax. Now, fortunately, they have restricted their search very, very, very small. Okay, so they are not saying overall x. If they say something like this, then maybe you will be doomed. Okay, you don't know what to do. But they have restricted their x, and on what they are saying, x should be the eigenvector. So they are saying that okay, you don't need to search in all the x. X is eigenvector, right? That's what they have said. Now, again, they have on top of that, they have said that x is unit eigenvector, which means see kx. Do you remember? Like x is eigenvector, so kx is also eigenvector. Now you don't need to search among all the eigenvectors, just search among the unit eigenvectors. Okay, x is unit eigenvector. So maximum among all the x where x is unit eigenvector. Like this is what question is saying. I mean, this is just a notation that people use, right? So basically, if you want, I can write like this, where x is maximum over all x, where x is unit eigenvector. They want to find out this maximum value. Okay, I think that's the question, right? Sorry, x transpose x. They want to find out this maximum value. Okay, now tell me how many unit eigenvectors will be there for A? How many unit eigenvectors? What do you think? A is 2 by 2 into 2 into 2 matrix. So there will be, at most I'm telling you, okay, at most I'm telling you, there will be 2 eigenvalues. Okay, if both are different, there will be 2 eigenvalues. And if there are 2 eigenvalues, then there will be, I mean, linearly independent, I'm saying actually, okay, 2 eigenvectors basically, right? And for every eigenvector, there will be a specific just one unit eigenvector, isn't it? So like what you need to do, you need to basically take both the eigenvectors, take I mean like just to put the let's suppose both the eigenvectors are x1 x2. You need to actually find out maximum of x1 transpose ax1. I mean, this will be some scalar number because this is a vector and this is a dot product of two vectors, so it is a scalar number. And then x2 transpose ax2. That's what you need to do. That's all. Is this question clear to everyone? I mean, we will solve it, but is the question clear? Let's just read out this question again. What is the maximum value of x transpose ax, where the maximum is taken over all x that are unit eigenvectors of A? Right? So actually, you need to take all the unit eigenvectors, and fortunately, there are only two. There are only two unit eigenvectors. Because there are there could be just two linearly independent eigenvectors, and yeah, all of the scaling is okay, kx is okay, like, but I'm talking about just different, right? And then in those two directions, just two unit eigenvectors will be there, just two unit, at max two unit eigenvectors are there. Okay, so basically your search is so small, you can do it manually, right? You don't need to differentiate, don't need to do all of this. You can just plug in x1 and x2, and then you can find out the maximum value. Okay, so I'm not going to do this. I'm going to do something else, which will even make my calculation even lesser than this. Yes, Supriyo, that's very nice. So I'm coming to that point only. Now they are asking they're asking that you need to find out the maximum value of this, right? And you need to search among all the eigenvalues only, or all the eigenvectors only. So basically it will be Ax will be lambda x. So this is x transpose lambda x. Since lambda is scalar, you can write it anywhere. You can write it here, you can write it here, you can write it here, anywhere. So which means this is lambda into x transpose x. X transpose x is nothing but x square. I mean, this will be basically the length of x, and length of x is basically they are saying that unit eigenvectors. So this is just lambda, right? ये आया थोड़ा समझ? So what I'm saying, let me just repeat this. Let me know if you have any doubt. See, what I'm saying, that you have x transpose Ax. This x transpose Ax, you need to find out the maximum value of this. Suppose I give you 50x, x equal to 1, 2, 3, or okay, just 1, 2. Okay, x equal to 5, 5, 4, x equal to falan dukan. I give you 50 different x. Then I ask you what is the maximum value of this among all the x. What you will do? You will just plug in the value of x and then find out the maximum value, right? Isn't it? If I give you 50x, that's what you will be doing. Now, instead of 50x, I'm just saying that I'm just helping you out. I'm saying that instead of those many x, just find out the maximum value of this among what? Among just the eigenvectors. And those eigenvectors are also unit eigenvectors. Okay, so basically there are just 2 unit eigenvectors that we have, and among those 2 you need to find out the value of this. So ideally they're just asking you the maximum value among just two vectors, 2 unit eigenvectors basically. Ideally they're asking to find out the value of this. Okay, let me know. Doubt solver, is this okay to you? Pooja Kumari, Satyam Naik. Okay, this is fine, right? Cool. So basically they're asking you to find out the maximum value among these 2. Now I can do it. I can find out those 2 eigenvectors. I can do all of this story, but I want to avoid it. Okay, I can find out those 2 eigenvectors. I can find out the unit eigenvectors. I can find out these 2 different values, which I can definitely do. But let's just not do all of this also. Okay, so what we can say, this x transpose Ax is nothing but since you are looking among just eigen vectors, so this will be lambda x. I mean, if this is lambda 1, it will be lambda 1 x1 or something like that. Lambda 2, then lambda 2 x2, something like that, right? So it is lambda you take outside x transpose x. And since this x transpose x is just 1, because you are only searching among the unit eigenvectors, so it is lambda, right? So they are actually asking you to find out the maximum value of this. The maximum value of this lambda will be, I mean, among the lambda 1 and all the possible lambdas. So among the lambda 1, lambda 2, it's just lambda, I mean, whichever is the higher lambda. Right? So basically this question is same as saying they're asking you maximum or the highest, or what should we say? Yeah, maximum eigenvalue, right? Actually they're asking x transpose Ax, but it is just maximum eigenvalue. You just find out eigenvalues of this, and whatever is the maximum, okay, your answer is the same one. So let's just find out this. 3 minus lambda 1 1, 2 minus lambda mod is equal to 0, and then 3 minus lambda into 2 minus lambda equal to 1, and then it will be 3, it will be lambda square minus 2 lambda minus 3 lambda minus 5 lambda plus 6 minus 1 plus 5 equal to 0, right? And then minus b plus minus under root b square minus 4ac. Yeah, 5 plus minus root 5, something like that, right? Yeah, upon 2a. And then you can check that this is the maximum eigenvalue, right? And this is not the maximum eigenvalue. Okay. So anyway, you can solve this question, but you need to understand that what they're asking. They're asking the maximum value of this, and this maximum value turns out to be just a maximum eigenvalue. What you can do, if you have understood this question, you can just answer on the gate overflow. I'm not sure that if that has been answered in that way. I want you people to answer. Like, I can obviously answer, but I want you people to answer in that way. Okay. So just write so properly that your comments get highest upvote. Okay. Your comment should get just a comment. Okay. Not answer. Comment should get 50 plus upvote. Write in so nicely, so step by step. No, these are in the Gate Overflow PDF only. I have taken from Gate Overflow PDF only. Okay. So this is the maximum eigenvalue. Okay. Interestingly, let me tell you one thing. Interestingly, they have given you so many hints, right? They have given you so many hints. X transpose AX. You need to find out. You need to find out only among the eigenvalues and so many hints, right? Only among the eigenvectors, that two unit eigenvectors. But even if you find, okay, even if you find, this is a machine learning problem actually. This is called principal component analysis. In PCA, you will see this same optimization problem. Even if you find X in R2, okay, then also this comes out to be the highest eigenvalue. Even if you find among all the unit X, obviously, like if you increase the value of X, if you do not restrict that X to be equal to 1, then it will be infinite. Like you can take very large X. That's not the point. So you have to make X to be unit. But if you keeping that unit eigen unit vector, even if you find among all the X, it will turn out to be the same thing that they have asked. Okay. Anyway, like this is a machine learning question. So in machine learning, there is called PCA, principal component analysis. From there, they might have picked this question. Okay. In PCA, actually, we solve this this optimization problem of X transpose AX. Cool. Is this, by the way, like as far as this gate is concerned, have you understood this? That X transpose AX is just the eigenvalue lambda. They have just asked the maximum eigenvalue, right? Okay. Now let's just see this. Consider matrix P whose eigenvectors are multiple of 1, 4, which means only one linearly independent eigenvector. Can you give me the dimension of P? Can you tell me the dimension of P? P has to be square matrix because they are talking about eigenvalue, eigenvector. Just 2 by 2, right? Because the eigenvector is 2. I mean, in R2. So it should be 2 by 2. So P is a 2 by 2 matrix. It should be like, I mean, not should be, but it may have two linearly independent eigenvectors. But they're saying it is just having one linearly independent eigenvector. So basically, only one linearly independent eigenvector. Now there is a concept called diagonalization, and which we do not need to know, which we do not need to study. They, in the 40 years, they have just used one of the option. So just because of one of the option, I don't want to, teach that particular concept of 1 hour. Not 1 hour, but yeah, it will take half an hour to teach diagonalization. I can teach it, but it is not required. Like we will see somewhere here and there, they will be asking some terms that is very, very rare. So if we think that we should not teach it, then we will not teach it. Okay. So diagonalization, we will not teach it. Do you just remember one thing, that a matrix can be diagonalizable? Matrix can be diagonalizable. What is the spelling? Diagonal. If and only if it has n linearly independent eigenvectors. Okay. I mean, actually, there is something called diagonalizable. You can diagonalize a matrix only if that has linearly, all the eigenvectors should be linearly independent. So, can I diagonalize this particular matrix P? No, right? No, I cannot diagonalize. No, it's not like can't say. It is just having one linearly independent eigenvector. and I need two linearly independent eigenvector. So that's why P cannot be diagonalized. That's true. P has a repeated eigenvalue. What do you think? See, there are two eigenvalues. Should P be having the repeated eigenvalues? Can have like different eigenvalues also? It must be having the repeated, because if it is having different, then only one linearly independent eigenvector is not the case, right? Must be repeating. P does not have its own inverse. That I don't know. Actually, for the inverse, I need to know about the lambda equal to 0. So this information is not a given. I don't know basically. Okay. Because they have to give me anything about lambda equal to 0 for the inverse. Now, which of the following is correct? Second and third are necessarily true, right? Second and third are necessarily true. Okay. So these are 3-4 questions that I wanted to discuss, because those questions are little unconventional, little tough. And apart from these questions, I think you should be able to do all the GATE PYQs. If there is any issue, then we will be doing PYQ marathon. Okay. So there will be a long class, PYQ marathon, I can call it, on the coming, not on this weekend, but on the next weekend. Okay. Yeah. On the Sunday. Okay. So just do all the PYQs of LA, and then we will make sure that in the live class you understand everything. So we will do all the PYQs in the marathon. Cool. So that is all. Actually, today I need to go somewhere, so I have to just end the class. Can you increase time for quiz? Yeah, we will extend the time, right? Oh yeah, we will do it. Okay. So thank you everyone. Take care. Yeah, thank you. So you will be getting nice photos, nice pictures, and nice videos from the felicitation. Okay. So thank you. Take care. Bye bye.